Hi, welcome to our tutorial for KiCad where we are going to be going over how to create the layout for our PCB. So now that we've finished up the schematic, we can go over here to the PCB Editor, which is going to allow us to make our layout. Okay, so now we have this blank canvas that looks a lot like the schematic page, and we see a bunch of different tools, options, and then over here are our different layers for what's going to show up on the page. So we'll be going over these throughout this process. And what we're going to start with is this button right here, which is Update PCB with changes made to schematic. So what this does is it adds the footprints for all of the different components of our schematic to this area so that we can arrange them and connect them together and design our layout. So we're going to hit this. We have this window opens up, shows all our different LEDs, our resistors, everything, and we can hit the update PCB. And so this here is going to give us all of the different components just thrown together in a blob. So we can zoom in on this and we see here we have our LEDs, here we have our resistors, mounting holes, the NMOS, the 555 timer, our terminal block, and then the capacitor. So now we have to figure out how are these all going to fit together. So first we can go through a few of the different parts that we see to these. So good one, we can look at the 555 timer. So we see these holes here. These are our through holes that we're going to be using to solder the timer to the board. And that's obviously quite important. We have to make sure that that doesn't overlap with anything because that's a physical part of the board. Then also we have this silk screen. That's this cream colored layer, and that's just a not electrically important part. It's just for humans to see and know, look at the board and figure out what's what. And then we have this rectangle here. That's the courtyard that just shows what space basically the component needs. And so we can see if we overlap that with some of these other components, they're all going to turn red. That says, we don't want that to happen. And then the last part is this fab layer, which has the part names and other details. So you may have noticed as I was moving this around, we have these different blue lines, and those are showing the different connections that we're going to have to make. This is all taken from the schematic. So we want to try to figure out what goes where. And a good place, I think, to start is with the LEDs. We know they're all going to be lined up together. So we can just select this whole block here, and there we go. So I'll move some of these off to the side. We can get to them later. Accidentally got that along that H with the LEDs. Got to be careful with some of those silk screen elements. I'll also turn off the fab layer for now. You see, here we can see all the different layers. We can hit this eyeball button to turn them on and off. So I'll move some of these off to the side just so we can get to those later. Okay, so here we have our 9 different LEDs. And so we know from the schematic that the D101, that's connected to D102 and D103. So we want these to all go together. And then also these 3 will go together and these 3. So what I'm going to do is we see we have this is the silk screen, and we want to try to make it pretty readable if someone's looking at the board. So we'll give the silk screen some space just to make sure that there's no terrible overlapping, although it doesn't actually matter. So we have that. I'll move these a bit closer to each other horizontally, just so that we can make a more compact board. So there we have our LEDs. And then another part of this that we can look at is the resistors. And so this R101, this is one that's connected to the 555 timer. So we can ignore that for now. We want the ones that are important for the LEDs. So that's these three here. So these we want to be relatively close to the LEDs just because they go together. So I'll move these over here, and we're gonna have to make connections between these points. And one useful tool to do that is the tilde key. We can select this hole here and click that, and it shows, okay, that's gonna need to be connected to those three. And then we can press the tilde key again to go back to our normal mode. So I'll move these resistors apart just for the silk screen readability. Then what other components do we have here? So one is this NMOS here. And this we know is kind of on the schematic. It goes between the 555 timer and this whole resistor LED setup. So I'll put that over here, and we can, like similarly to the schematic editor, use the R key to rotate. So I'll just put this right up here for now, so that we can easily make these connections from the NMOS to the LEDs and the resistors. So we can hit this port here. That's the one connected to the timer. This one's the one that goes to the resistors. Okay. So then if we're just kind of making an imaginary box around this, we see we have a bunch of space right here that we can use. And one important thing is, so the 555 timer, this is our central component. So we want this to be in an area that's relatively accessible to everything. And so I'm just going to put it up here for now. And that'll give it proximity to the NMOS, and then also to the terminal block, the capacitor, these resistors, which I'm thinking of also putting in this area. So a lot of this is just going to ultimately be some trial and error. You have to play around with things and figure out what works. But I see some potential for these. We can move these three resistors down here, and now we have some space for the capacitor, the terminal blocks, and these resistors. So I'm going to rotate this so that it's flat this way. And then we know that these resistors and the capacitor, these are going to be connected to the threshold marker here. So these components can all go down here, since that's what they're needing connecting to. So I will move these over here, and then the capacitor can go over here for now. And then we can hold off a bit on the exact positioning of the terminal block and these mounting holes. The mounting holes are not connected to anything, they're just physical parts of the board, so that's really our last priority. So I'll just rotate this terminal block here so it'll fit a bit nicer into this imaginary box we've got. And then one other thing we can do is move around these silkscreen labels. We can again use the R key. Okay, so this is a basic start to our layout. But really what the most important part of all this is drawing our traces, our wires between these different components. And so once we start doing that, we may notice changes we want to make to this layout that is going to make it easier for all the wires to fit together. So the most important layer here is going to be these copper layers. And we're going to just try to make a simple one layer board here. And that means no going over to another layer so that we can essentially cross lines. It just makes it more simple from a visual perspective. So we currently have this front copper layer selected. This back copper layer is also here if you're going to make a two-layer board. Unfortunately, KiCad does not allow us to set it to one layer, so we have to work with that. But so we can start by selecting this Route Tracks button here. And let's just go back to our resistors and our LEDs. So this port here connects to these three right here. So we can notice one thing that we can do is just to make this side here closer to this. And so we can do that just by rotating this one. And then I'm just going to bring the silk screen label back up to the top. And then here, now this is a bit closer. And I'll repeat that process for all of these. Again, gotta move silk screen labels. Okay, so we come over here to our route tracks button, and we notice that none of these angles it's creating just automatically as I drag around the cursor, none of these are 90-degree sharp angles. And this is because we want to mostly keep it to 45 and other degree angles, just nothing that's very sharp and is going to make it difficult for the current to flow through these traces. So what I'll do here is click at this point just to, because that's where I want to make this go, and then bring it up to this port here. And next, what I can do is hit the X key, and that's just a keyboard shortcut for routing these tracks, and bring this over here, and it does all that automatically. And so you'll notice we do want to go around this ground here. We don't want to get too close. And same thing goes with actually putting the different traces next to each other. We want to try to give them a bit of space whenever it's possible. And I'll do this here. Okay, so that's a similar idea of what we want to do with all these resistor LED groupings. So I'll keep doing that here. Oh, and we've got to rotate these ones around. Bring the silk screen up. Just gonna play around here, see what's best. All right, I'll keep it at that level. Rotate it. And I'll move on to these three also. Okay, so then one thing I will do is see if I can move these down a bit. Just select them all, make them a bit more in line with these resistors here. And you will see that gives us a bit of an issue. We're going to have to do some rerouting here. So I'm just going to delete these traces here to redo that. Okay. Now, so as you can see, there's lots of trial and error, but it's all pretty simple stuff. So now we'll connect this here, bring this over here, and now we're done with that step of the process. Okay, so now we have these resistors, and these are all going to be connected to our NMOS up here. And you'll notice that there wasn't any issue for the traces going through the silk screen or the courtyards, and that's just because really the electrically important parts are just these right here. So traces can go a lot of places. We have a pretty good amount of flexibility. So I think what I will do here is we're going to need to draw a trace from this up here, and we don't want to really get in the way of any connections we're going to make with these two resistors, and I don't want to go too tight through here. So what I'm going to do is just move these two resistors over a little bit. Maybe don't have to do that, but it makes things a little bit nicer. I'm going to make this connection here. Just going to bring it up. And I'm just going to go around behind this. Oh, and you see here we have a right angle. We don't want that. So I'm going to undo that, bring this up, and there we go. And I'm just going to leave that on that side so that we can more easily get to these ports here. See, this is going to the 555 timer. This allows us to have a pretty direct route there. Okay, and then we can make these connections between the resistors without any issues. Okay. So next thing, since I alluded to this before, we can connect those. I think what I will do, I'm going to move these labels just to make them all upright. Put this one down here, this one up here. And one thing that I'll just put all of these R101, R2, 103 in line with each other. And then I can move this over just a little bit. Move it down. Actually, this I can move down also. Just want to try to make that a little bit more compact. It really doesn't matter for something simple like this, but when you get to complicated things, you want to try to fit it all pretty nicely. Okay. So now we can make this connection here. I'm just going to go like that. Pretty simple. Okay. So now this part of the board is mostly done. You'll notice I'm leaving out the power and ground. We can get to that last. That's kind of can be more complicated, but also we're just gonna fix this right there, make that not a right angle. Okay, so now we can move on to this threshold, these threshold signals. So that's something that's connected to a lot of stuff over here. And I think what I will do is flip around this resistor to make that threshold part a bit closer to this port here. I'm going to do the same for the capacitor. Okay, so now that's just a bit closer to everything. And we can connect those together. So one thing we could try to do is, there's a clear connection right there, but no, we can't do that because then we'd be crossing these traces and we're going to have all sorts of problems with that. So instead, what we can do is just go around here and do something like that. Okay. And then this here and this, I'll bring it down like that. Okay, perfect. I shall redo that. Make a, yeah, that's good. Okay, so then these here are connected like that. That's pretty simple to do, just like that. Okay. So now, if I'm not mistaken, really the only things that we have left are 9 volt and ground. So 9 volt, that's connected to a bunch of different things. Let's see. Okay. So this resistor here, NMOS, and then the 555 timer. Okay, so that shouldn't be too hard of a connection. We just have this here, then we can come down through over here, and then we have all this space there. So I'll do that. And then we can make this connection go up through here. Do this. Oh, don't want that right angle. Okay. And then we come over here and then right there. All right. Great. And I will drag this down just a bit. Okay. So now the last thing that we have is ground. And what we can do for that is, it might be kind of a hassle to make all these different connections. Ground something we are using on the vast majority of these. So what we can do instead is to add a filled zone using this button here. And so what this will do is essentially make it so I'm just going to draw this box right. Oh, we're going to start there. Okay, and so you see when I bring it up, we can make this ground, and then it basically acts as a kind of massive trace, so to say, so that everything, go back here, in this zone is all going to be connected. You can hit the B button to fill the zone, So you can see here, all this is going to be ground. And then what we do want to do is we can double click on this to open the properties, and you'll see these pad connections here. And what we can do instead is change that to solid and then hit our B button again, and that'll completely cover that. That's a bit nicer. Okay, so now everything should be connected. Okay, so then our last part to add to our board is the mounting holes right here. So I'm just going to bring this area out a bit so we can bring these in. And I'll put one of them up in this corner and then another down in this corner. And then one thing that we can use to make sure that these are aligned as if we're like attaching them to something, a completed PCB, we can select both of these and see this align slash distribute option here, and we can align to horizontal center, and you can see that this one moved just a tiny bit. So now these ones are going to be like straight up and down. All right. So now to get on to one thing that is quite important, but we haven't talked about yet, and that's just because it's something that we can take care of kind of at the end once we have our completed area, and that's the actual boundaries of the board. And so to do that, we can go to this edge cuts layer and then just draw a box using this rectangle button here. And I'll bring it in a bit. So here you see we've got this here. And right now it's 44.45 by 29 millimeters. So I think ideally we'd like to get a pretty nice number there. So what we can do is right click and change our grid size, bring it down a bit lower just to so we can have a bit more precision. Get pretty close to 45 and 30 because that's what we're looking at here. Okay, and now we can change our grid size again to 0.1 or sorry, 0.01, and then got to exit out of the rectangle tool. We can bring this, I'll zoom in a bit, bring this in just one. You can see in the bottom left, it shows our width and height. Got to get this to exactly 45, and then the bottom to exactly 30. Okay. So now we can kind of put that right there. And then we can change this zone here to match up with that. So what we want to do is try to center it pretty well on the edge of our board. Doesn't have to be exactly precise. Okay, so that should be pretty good. We can hit the B key to refill our zones. All right. Okay, so then one thing I want to just move this around a little bit, try to get this area up here filled in. And so I'll just I'll turn down my grid size, 0.25, just for a little bit more precision. I'll move this up just a bit, and then this up. That's going to make it not our precise 30 millimeters anymore, but then we just move each of them up again, and that should be good. We can hit B again to refill our zones. There we have connection all the way around. All right. So now we're mostly done. We just want to make a few final changes. And one of those is we can go to this user drawings tab and add the measurements to the edges of our board. So to do that, we click on this tool here, add an aligned linear dimension. And then we'll look here, we want to select the edge cut. And then go down here. And then that's, oh, looks like we selected one of them wrong. It should be exactly 30. I can just check to make sure that yeah, okay, so that is 30. I'll go back to user drawings, select this. All right, and there's our 30 millimeters. And then we could drag this out a bit to the side just to make it a bit clearer to someone looking at this layout as to how big the board is. Okay, looks like I selected something wrong there. Gonna go here, and there's our 45. We'll try to make these nice and even. Just like that. Okay. So now what we can do is go to the silk screen and we can add some text and labels to things. So one thing that can be useful to do is with these terminal blocks here is to indicate which one is the positive and which is negative. So what we can do is add a text item here, and we'll just add a plus symbol. And then we see these options here we can use to position it where we want. And then I'll place it right about here. And then we can figure out the exact positioning later. So then we can add a minus symbol, same kind of thing, right here. And we do have to rotate this one. Okay, so we want to try to make this pretty, line these up with these holes right here. So what we can do is in this symbol, we can right click and go to locking and hit lock. So that'll make it so that we can't move this around if we want. We get this error here. So we can use that align tool from earlier with the mounting holes with this, and now the terminal blocks won't move at all if we try to align these. And so we do have to use that tool, we have to check this locked items box in the selection filter just so that we can select these together. And we can right click and align to vertical center. And we do see that moving down a little bit. And then we can repeat the same thing for these two. align to vertical center. All right, so now that's all good. Now we can align these two together, and I will do align to horizontal center this time. Okay, so now we can just unlock this. All right. Now, another useful piece of text that we had on our schematic is just a warning indicating to someone using this board that we only want a 9-volt input. So we'll add a text box, say only 9-volt input or 9-volt battery. Okay, and I will center this in the text box, and then we can rotate it just to fit it over here. I'll put it, I'll make this a little bit smaller just so it'll fit a bit better in that gap. I'll change the height and width to say 0.9. And then we can drag this right here. And I'll just place this right there. Okay, perfect. And then we can also put our title on the board. Actually, one thing I'll do first is just, we don't need these silk screen labels for the mounting holes, as those aren't actual parts. We add our title here. This is our 555 timer demo circuit. So then we can center that in the box, rotate it, and then try to center it on our board here. Let's say that's pretty good. Okay. So then this is pretty much finished. One thing that I will do, just since this is a 2-layer board, even though we don't necessarily want it to be, is to go to the back copper layer, and I can just fill all of this in with a zone on the back. Go again, hit add a filled zone. Go right here. Oh, looks like I need to change my grid there. Okay, we're doing ground again. Again, this isn't entirely necessary, but just will make this design here a bit complete, since KiCad can't do only one layer. Make sure that's all good. Okay. And then we hit B again to fill it. There we go. Oh, okay. All right, so then last thing we can do is to edit the actual drawing here, this outline and this area here. So we can just double click right here, and you'll notice that we have a lot of empty space just because our actual board is not very big. So we can change the size down to A5. And then our issue date is just going to be today's date. Our title, of course, is 555 timer demo circuit. Company, we're the Illinois Space Society. And then it's customary to put also the contributors to the board, and just put your name right here. And then the last thing we can do, this is revision A. Okay, so that is our board. We can just move it over to the center here. And that's it. One last thing that we can do to make sure this works is to look at this design rules checker window, and that's just right up here. And this will just run a basic check to make sure like everything's connected. There's not any overlapping. Can run DRC. We get 0 errors, 0 warnings. That's perfect. So now this is our finished board. You can make any changes needed to make sure it's all good to send off for manufacturing. As always, have fun creating your own boards and good luck with the process. Thanks for watching.